Heat and cold in medicine. General properties of heat and temperature. By Assistant Professor of Medical Physics, Dr. Al-Arif. Heat and thermal energy. Heat is the mechanism by which energy is transferred from one object to another. Energy has many forms such as kinetic energy, gravitational potential energy, chemical potential energy, thermal energy, electromagnetic energy, nuclear energy. Naturally, energy is conserved. Therefore, energy never destroyed nor created, it can only be transformed from one type to another. Thermal energy and temperature. Thermal energy is defined as the sum of all disordered forms of energy within the object. The disordered forms of energy refer to all energies that makes the molecules and atoms to agitate, rotate, vibrate, and excited. Therefore, thermal energy is an internal form of energy. Temperature is defined as the average kinetic energy for the individual atom or molecule within the object. Temperature also indicates the direction of flow of heat energy between two objects, the degree of hotness or coldness of the object, the intensity of heat energy, the amount of thermal energy per unit area. Temperature equal to thermal energy per unit area, heat and temperature. When two objects in contact but do not exchange heat, we can say they are at thermal equilibrium. Heat is the mechanism of transferring energy from one object to another due to a difference in temperature. As in the figure and by definition, if heat flows from object A to object B, then object A has higher temperature than object B. Naturally, molecules or atoms are under motion. It stop moving completely at very low temperature called absolute zero temperature. Temperature scales. 3 types of temperature scales are used throughout the world. Celsius scale, the freezing and boiling points of water are taken as a reference, in which water freeze at 0 degrees Celsius and boiled at 100 degrees Celsius at 100 kPa of pressure. Fahrenheit scale, the freezing and boiling points of water are taken as a reference, in which water freeze at 32 Fahrenheit and boiled at 212 Fahrenheit at 100 kPa of pressure. Kelvin scale is the basic unit of temperature in the SI unit system. The scale started at absolute zero temperature and used the triple point of water, a temperature at which water can be found as solid, liquid and vapor at the same time, therefore a 273.16 was used as a reference point. In this scale, water freezes at 273 Kelvin and boiled at 373 Kelvin. Kelvin scale is related to Celsius scale by Kelvin equals to centigrade plus 273. A diagram to show the differences between scales. Temperature and heat energy. In the following pictures, which is hotter, higher temp, the candle or radiator? Which gives more heat energy? To answer that, the candle gives little heat energy in very small area. This is why it can't heat the room. The temperature, intensity, of the candle is high. Radiator gives more energy over large area and it can warm the room, but the temperature, intensity, of the radiator is low. Feeling of hot and cold. Heat is the process of transferring thermal energy from hot to cold objects. The faster the heat transfer, the more you feel its hotness or coldness. A good conductor to heat is a material through which conduction of heat is easy. Metals in general are good conductors of heat. Free mobile electrons are the reason why metals are good conductors both of heat and of electricity. Poor conductors is the one that is difficult to conduct heat, such as wood, plastics, glass, and air. Heat transfer mechanisms. Heat is transferred from one object to another by one of the following mechanisms. 1. Conduction, in which thermal energy flow through a stationary object via direct molecular collision, as in the figure. 2. Convection. Convection occurs when a moving fluid carries thermal energy from one point to another. There are 2 kinds of convection: natural convection, in which the fluid moves by its own buoyancy as in the figure; forced convection, in which the fluid is forced to move by a fan or pump as in the figure. 3. Radiation. All objects according of their temperature, emit electromagnetic radiation, which carries heat. It is different from conduction and convection as it requires no matter to transfer. Radiation energy will pass perfectly through vacuum as well as through clear air as seen in the figure.